before I move on to the last chapter I'm going to spend the majority of my time on today, just want to highlight a few common mistakes I have found in marking paper 1. So if I go over to the next slide, the common mistakes, ladies and gents, and I want you to make stars next to the ones you know. When looking at algebra and equations, when doing surds, the ones with the square roots, that's the worst answered questions in algebra and equations. Why? Because students don't isolate the surd before squaring, then you get 0 automatically, and you don't check your answers. Put a star next to that one, please. You don't want to lose 1 mark because you didn't check the answer. Most common mistake I found is students also don't know the difference between undefined and non-real. When is something undefined? Oh, please. Let me define my question better. Sorry for the dad joke there. What does undefined mean? And now some of you know solutions. Oh my goodness, you guys must be untrained. Okay. Undefined means goes against a definition. That's what undefined means. It doesn't mean there's no solution. It means it goes against a definition. That's what undefined means. Now, what definitions are there in maths? 3 of them. Yes, sir? Yeah? Cannot divide by 0. Why not? Because it's a definition. Now, please get this, ladies and gents. There might be some very awesome mathematics professor in the world somewhere that gets a set of numbers where you can divide by 0. Now you're like, oh, sir, no, it will never be. Ask the physicists. Quantum physics came along. All of a sudden, an atom can be at 2 places at once. That's part of quantum physics. Did they now throw out the whole, everything that Einstein and that Newton and those guys did? No. They made a special branch of physics just for those particles. So it could be possible that in a few years' time that will happen. Can't divide by 0 because then, like, all of maths would have to be thrown out. Because it goes from the basics, I can't divide by 0. What other undefined places do you have? Yes? Nope. Sorry, that's not undefined. That's non-real. Undefined means going against the definition. Okay, be careful. Non-real just means, it doesn't mean it doesn't exist. It just means it's not real. It's not part of the real numbers. Now you might come and say, but sir, it kind of feels like the same thing to me, right? No, I get that. Let me quickly show this for you. Okay, sorry, let me just quickly do this. I want to show this for you so you understand. If I take the square root of -3, non-real, right? But what if I square that? Non-real just means there is no number in the normal mathematics that you and I use in everyday life where a number squared gives me a negative number. That's just what non-real means. But undefined literally means it cannot happen. There's no way it can happen. So the first place was? Divide by 0. What's the second place? Come, Matrix, you must know this stuff because it can be asked. What about log of a negative number? Woo! Log A of x. What do I know? A and x must be greater than 0. That is a definition. So if I tell you log 3 of negative 2, that is undefined because it goes against the definition of the log function. That's undefined. What is the next number or the next kind of undefined? The last one we look at. Whenever I have something like 2 to the x being negative 3, x is there undefined because there is no possible value for x that would yield that solution because there can't be a solution. So please untrain your mind to just think about undefined as being no solution. Undefined means going against the definition. So we love to ask this in weird ways, depending on the question. We love to do this, and I'm that kind of a teacher that asks questions simply because I know students will not get it right. I'm a horrible human being at times. What expression, not answer, please get my question, expression would give me non-real in P of x? What expression would give me non-real values? What did I just say to you? Non-real means a negative under the... Okay, so if I ask you for non-real, it would have to be x squared minus 4 smaller than. But if I ask you for undefined, okay, if I ask you for undefined, sorry, let me just write it, then I'm talking about x squared minus 1 equal to 0. There's the difference. So we ask it in the exam in such a way that if you think undefined is a negative under root, you lose all the marks. Because then you would look at x squared minus 4. Please be very careful. That's why I say it's a very common mistake. In roots, how many of you, the moment you hear roots, what's the first thing you think of? If I tell you the roots are non-real, what do you think of? The discriminant must be smaller than? Common mistake, using the discriminant in the wrong place. Please, ladies and gents, common mistake in paper 1. Roots just mean solutions. Roots mean solutions. Only when it is in a quadratic equation can I use the discriminant. So if I tell you the roots are equal, it means the solutions are the same. Don't just go towards delta. That's another thing, especially the IEB have asked us as teachers to stop doing, is stop teaching roots as just for discriminants. Because they want you to understand roots as being solutions to equations. Common mistake. Next one is not checking answers in fractions. Forget that there's undefined. And the last one, which is my pet peeve, is not drawing graphs for inequalities. Some of you use the table method. I feel sorry for you if you do that. I'm just preferential towards drawing graphs. But inequalities will be there, so you've got to make sure that you do it. Yes?
So like what about using the number line?
That's the table method I talk about. I hate it. The reason why I hate it, personally, it takes for me too much time. But if that's the way your teacher teaches it, I'm not going to judge too harshly. But ladies and gents, the common mistake here is that a lot of you, when you answer inequalities, You forget to either draw a graph, a number line, or a table. You just want to go x minus 1, x plus 3 smaller than 0, and then just straight off go to your answers. You cannot. There has to be a method in between the 0 and your solution. If you are unsure about that, please come to me and I'll sit with you and we'll do 1 or 2 sums. Okay, I don't want to spend our time on that. I just want to highlight that. In sequences and series, common mistakes is students getting confused between Tn and Sn. And the problem is, if I choose the wrong formula, look at that. How many marks? 1. If you use the wrong Tn or Sn formula, 1. They don't look further. So you've got to be careful. Are we asking for term value or total? That's where your mind has to go. If it's total, then it's Sn. If it's actual, just term value, it's Tn. Same with financial mathematics, my favorite, but I hate it. I hate marking financial maths. Because like half of my students use the F value instead of the P value. I wish we had more time. Okay? But in these two, and I'll put it on the same slide, you have to make sure, ladies and gents, you choose the right formula. If there's any of you that are struggling, especially with financial maths, to choose the right formula, after we've done this session, I'll stay behind for 5 or 10 minutes. And I'll show you the method I use called the decision tree. It works fantastic. Then, please don't forget about effective versus nominal. It's the one formula we don't give you, therefore we will ask it of you. It's just the way we roll. Functions and graphs, we've spent a bit of time on now. Just one little thing that I just want to highlight about functions versus non-functions. Please, using the vertical line test is not an exam reason. If you didn't know that, now you know it. You have to say something like, it's not a function because for one x value, there's more than one possible y value. If you say it doesn't pass the vertical line test, they don't mark it. You are not allowed to use the vertical line as a reason. You can use it as a way of checking, but not a reason. Okay, the examiners made it very clear in the past few years. Function notation is horrible, unfortunately. Calculus, you can work through them. Please, formulas for 3D shapes. Prisms, like boxes and cylinders, they're not going to give you their formulas. They're not. But pyramids and spheres, they're going to give to you. So you have to know it. Then, ladies and gents, the next 40 minutes, we only have 40 minutes left. We are going to look at probabilities. Why? Because you guys suck at it. Honestly, every year I mark probabilities and oh my goodness, my students get so confused with when to use what. And it's the one chapter as well that you cannot go and Google. Please don't Google it. Because if you're going to Google it, they're going to go into first year varsity in the first 2 minutes. Guaranteed. Because the way that our probabilities are structured is it stops just before you get to first year varsity, and then they just confuse you. So I'm going to talk about probabilities for the next 40 minutes. No, I'm just going to talk about it. We're going to do some sums. For me, That is a very crucial section. This whole section is very crucial. And it's actually quite simple. So what I'm going to do is I'm going to ask you, this was a question that I asked in the prelim exam for this, for my matrics this year. Okay? It's on there, it's on your notes. Each letter of the word sealant is written on a card and placed in a hat. A card is drawn 3 times without replacement. Calculate the probability of drawing 2 A's out of the 3 cards drawn. Okay? Hands on the head. What tool am I going to use, matriculants? Counting methods, Venn diagram, tree diagram, two-way contingency table. What method am I going to use? Okay, who's on this side? Who's willing to put up their hand? Okay, I want someone at the back there. You guys are all quiet, the ladies there. Yes, sir. Tree, why?
Because it's non-repeating.
What if it was repeating? So you understand why I'm asking you the question, why? Who can tell me, he's right, you're right, it must be a tree diagram, but why? This side, top here, you are all ladies and gents, very quiet here. Why a tree diagram? In the middle here? Come on, matriculants, it can't be like this. Then how do you know it's a tree diagram? Do you smell it? Yes. Then you might not have showered this morning. Or your mate, I don't know. Okay? Guys? Yes. So what? Venn diagrams are also more than one event.
They happen at different times.
Ah, it's events following on one another. Therefore, it has to be a... Okay, so now you can put your hands down. When do I use a Venn diagram? It's also more than one event. But when do I use a Venn diagram? Come on. Ray, what do you say? Okay, so when we're talking about choices, I can choose more than one thing. Okay? And I want to know how those choices influence one another. Then I'm going to use the Venn diagram. What about the two-way contingency table? Some of you are like, I don't even know what that is. It's that one where they go male and female, sport and no sport. Oh, that one. When do I use that one? When I want to check independence. Does male and female affect whether they're going to do a sport or no sport? So you've got to get that in your head. Tree diagram, events following on one another. Whether it's dependent or independent doesn't matter. Events following on one another. Venn diagram, choices. Two-way contingency, independence. Do the factors influence one another, yes or no? Okay. 5 minutes, go for it. Answer this question for me. Ladies and gentlemen, when we look at something like this, okay, I did this on purpose, and this was one of the worst answered questions in our prelim. I don't know why I do this to myself every year. Okay, I love to ask these kind of questions. That's why they call it a Mr. VG special. Okay, When I look at this question, ladies and gentlemen, there's a few important things for you to know. First of all, how many cards are drawn? Hello? 3. That means my tree diagram has to have 3 sets of branches. Not 3 branches, 3 sets of branches. But please, do not look at S-E-A-L-A-N-T. In the end, if you do that, your tree is going to be, you're going to sit with about 343 possible branches. But what's the question about? Drawing an A or not drawing an A? So there's my 2 branches. I'm not worried about what the other number is. So I'm just going to say, in my first set, I'm going to draw an A, or I'm not going to draw an A. That's my first options. So this becomes 2 out of 7 and 5 out of 7. Please understand how a tree diagram works. If I go to the top branch, I have drawn an A. How many A's are left? 1. So now I can draw an A or not an A. There's only 1 out of the 6 cards that's now an A. But ladies and gentlemen, that means that 5 out of the 6 is not an A. But now I've removed all A's. So if I walk this from that A there, I just have the option of not drawing an A. And that is 5 out of 5. Logically, it means there's no other choice. 5 out of 5. The probability is 1, 100%. But now if I walk this road, ladies and gentlemen, and I go A, not A, then I can again go A or not A. I've still got 1 out of the 5 that's left, that is A's, but I've got 4 out of the 5 that's not A. So let me give you a tip. Don't draw the whole tree diagram. Think about what options do I have. I have A, not A. Then I have A, not A, and A. Or what's the last one? Not A, and A. That's all the options I've got. Everyone is with me. So that's all part of the tree diagram I have to draw. I don't have to draw the whole tree diagram. So I've already got this one. A, not A. Let me use a different color there. Okay. I have A, and not A there. I've got A, not A, and A there. Let me again use a different color. So A, not A, and A. What is the only other leg that I still actually need? Okay? Not A, then A, and A. So this is going to give me again 2 out of 6 there. And then I have 5 left, and I have 1 option there. Okay, now here's a beautiful little trick. I wish my teachers taught me this trick. There's 2 important words in probability that you are going to hear a lot in matric. And, or. When you hear or think the word and, you use multiply. But when you think the word or, it means addition. So I've got 3 options. So I've got this, or I've got that, or I've got that. Because I'm using the word or, options. So I'm adding them together. So what is the probability of A, not A? 2 out of 7 times by 1 out of 6 times by 5 out of 5. Everyone is with me? What is the probability of getting A, not A, and then A? So in other words, the red one that I highlighted there. What is this probability? 2 out of 7 times by 5 out of 6 times by 1 out of 5. Everyone with me? Is there anyone that's not with me? Please put up your hand. Yes.
So once you multiply the probability of A and not A,
What do I use in between that? I'm going to walk A and not A and A. The moment I think about and, I multiply. In probabilities, that's how we work. So I'm going to walk here and then there and then there. That's how I use it. Do you see that those two probabilities are the same? How many of you see that they are the same? Look at the denominators. Look at the numerators. They're all the same. 215, 765. They're all the same. So all three of them, interestingly enough, ladies and gentlemen, sorry, let me not do that. I can actually simply say times by 3. Even if you go not A, that's 5 out of 7, times by 2 out of 6, times by 1 out of 5, you're still going to get the same one. So the shortcut in this case, not every time, in this case, not every time, in this case, I say times by 3. But it's not always like this, so please, 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 it's on camera, so you can't go back and say, oh, it's always going to be times by 3. No, it's not. So someone asked me earlier, why do I not use counting principles here? What are counting principles all about? Who can tell me? Matrix, you've done a whole chapter on it. How can you not know what it's about? Come on. Someone put up their hands. Please, what are counting principles all about? Yes.
It's about calculating how many times a event can occur.
Okay. It's about calculating how many options we've got. That's it. That's what counting principles are all about. So please don't, just because you see a word like sealant and all of you automatically, how many numbers are there? Factorial. No. You've got to actually read the question. That's why I asked this, because I wanted to catch my students out. I'm a nasty, nasty teacher, or rather nasty examiner. So what I'm going to do, ladies and gentlemen, is that is the second last question on your question that I handed out to you. If the word relentless is shuffled, now we're talking about counting principles. Why? Because the question is, what is the probability of starting and ending with the same letter? So I need options. I need to know how many options are available. So I'm going to give you a quick... Yes, time is running out so fast. We only have 18 minutes left. Okay. Let's have a look at the sum. And let's analyze this question, ladies and gentlemen. If you want a tip from a fool, i.e. me, okay, draw pictures. So relentless, how many letters are there? 10. Let's see, 2, 4, 6, 8, 10. So in other words, what do? 10 letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Automatically, ladies and gents, all of you are going, okay, N of S. 10 factorial over. How many different repetitions are there? The E repeats itself. Oh my goodness, that's not working out today. 3, there's 3 of them. How many L's are there? 2 of them. How many S's are there? 2 of them. Is there anything else that repeats? So that is the E's, the L's, the S's. Everyone's all right with that. Why do I need N of S? Why do I need N of S? So, somebody? Let me ask there in the back. Come on, you guys are all so quiet. Why do I need N of S? So what do you say? Somebody else? Yes, there. I love it, yes. But why do I need it? Because I'm looking for probability. If the question was just in how many ways can it start with the first and last letter, would I need N of S? No. But because I asked for probability, I need N of S. Please get that. Usually this would already be asked previously. Now, how do I do a sum like this? Let me teach you a secret. With probabilities, in your mind, you must always ask yourself, is it in a box or is it in cement? What's the difference? A box can move, cement can't. In this case, what is the question? What is the probability of starting and ending? So is that a box or is that cement? It's cement, because that means I'm putting my first and my last letter separate. So in other words, put it in cement. Put it in cement. But here's the secret. Please get this. There are 3 what? Options. So I know I'm going to add probabilities together. Or I'm going to add the number of ones together, because I could have an E first and an E second. I could have an L or an L, or I could have an S and an S. So I've got 3 different options, so I've got to look at 3 different probabilities. And they're not going to be the same, so don't just go with this stupid thing of saying times by 3. Why are they not the same? There's one that is the bugger. The 3 E's. Because if there are 3 E's, let's quickly look at this. And this is important. Now, I want to do this. So I'm going to take some time on this one, ladies and gents. I'm going to take some time on this one. If there are 3 E's, how does the rest look? So if I've got E and E, they're in cement. Then I've still got an R, an E, and L, a N, T, L, S, S. Here's my question. Those ones in the middle, in how many different ways can they be shuffled around? in 8 factorial over 2 factorial times by 2 factorial. So that is the ones in the middle. Now what about the e's? Does it matter if they are swapped around? No. So there's just one option. Because whether I swap the e and the e around, it's not going to make a difference. When will this not be like this? What if I talk about people? If I swap you and you around, does it matter? Yes, because you are different. So then you're going to have to be, I've got 2 options there, but 1 option there. So you've got to be careful. In this case, the e's are the same. That's why I'm going 1 and 1. But what if I put an L and an L there? Okay, what if I put an L and an L there? If I put an L first and an L last, what have I got left in the middle? I have an R, E, E, N, T, E, S, S. So now how many different ways can those middle ones be swapped around? 8 factorial, 3 factorial, and again, 1 and 1, because it doesn't matter if it's swapped around. Ladies and gents, is this the same as this one? Oh, be careful. You can't just say times by 3. But I can tell you the following. The L and the S are going to be the same. So this one, I can say times by 2, because they are going to be the same in the middle. But be careful of the other one. So when you are wanting to put things in cement, it means they're not going to move from the end places. Then you look at the rest. But don't forget about those end places to look at those options. So let's do a last one or two. This one came out of the IEB exam of last year. Five cards are drawn. What is the probability that 2 letters will never be next to one another? What do I do with something like that where it says, what's the probability of them never being next to one another? Who can tell me? What am I going to do? Yes, sir. So the probability of not together. Okay, let me just write that out proper. Is equal to 1 minus the probability of them actually being together. Now the question is this a box or is it cement? Is it a box or is it cement? Can the box move? Yes. Can the box move? Yes. Because we just worried about you two sitting together, right? So if I move, the box can move. So what I love to do is draw pictures. Let me put my 3 letters, or my 2 letters, the A and the B, in a box. And that box counts as one whole thing. So how many options do I have? 1, 2, 3, 4 factorial. But don't forget, what about inside the box? Can they swap around? Does it matter if they swap around? Yes. So I'm going to say times by 2 factorial. What if it was an A and an A? Would it matter if I swap them around then? No, so then I would say times by 1. So be careful. So in other words, when things are in boxes, put them in boxes, and don't forget to look inside the box to say times by 2 factorial. Why again do I use times by 2 factorial? Because I'm using the word and. The box can move, and inside the box can move. So please be careful when you're doing probabilities, whether they're asking you to put things in cement, means they can't move, beginning and end, or whether they say just together, that's a box. But don't forget inside the box. Ladies and gentlemen, as a lacquer challenge, 2 minutes quickly. What is a probability that the code will start and end with a number? Quick, 2 minutes, quick. 2 minutes. Don't worry about probability for me actually in this sum. Just go in how many ways can it start and end with a number? Just the number of ways. Don't worry about probabilities now. Okay, so let me first ask, box or cement? Who's saying box? Okay, he's like, no one else. Cement. Who says cement? Those of you that's saying cement, you're wrong. I'm joking, you guys are right. Okay. It is a cement sum because I'm saying 2 things are staying put. So I'm saying cement and cement. And then inside, I've got 3 things that I don't worry about the order. So let's start inside. That's easy. I'm going to have a number in the beginning and the number in the end. What am I left with? I'm going to be left with 1 number and 2 letters. Does it matter which order they are in? No, so this is going to be 3 factorial. But now, here's where it becomes interesting. When I look at this first part in the cement, how many options do I have to choose from? Yes? Say again? 3. It could be a 1, a 2, or a 3. Now I've picked one of them. How many options do I have left for the last part of the cement? 2 of them. So your answer is 3 times 3 factorial times by 2. And that is the number of ways it can start and end with a letter. Okay? Box and cement. For those of you, ladies and gentlemen, that's up for a nice challenge, I challenge you to go and do the last question. Not now, but when you leave or before tomorrow. Okay? I want to challenge you because this actually came out of last year's IEB paper. Okay, I'm not going to go through it. Okay? What I am going to do, rather, ladies and gents, okay, is I want to just for a moment have your attention. Okay, I'm just going to quickly switch this off. Okay. Okay, I want to have your attention for the next few minutes before we leave. Paper 1 is one of those places where you can score a lot of marks if you practice enough. But practice is not enough. So how do I fill my toolbox? From this moment on, ladies and gents, till you write your paper 1, you need to strategically go and look, where am I struggling? How do I do that? Well, go and get your prelim paper. Ask your teacher for your prelim paper and look at which sections didn't you have a cooking clue about. And sit with a buddy or 2 or 3 or 4 and have conversations. What am I missing in these chapters? But please, I want to encourage you, do not get stuck there. If you are on a 60% and you need to get to that 70%, it's a start, but you mustn't get stuck there. So go and ask yourself, if you look through all of those columns that I put on that on the paper we handed out, go and circle which ones do you need some help with, and get to someone that can help you with it, whether it be a teacher, a friend, whoever. Then you need to start practicing. So tomorrow, in the session, the last 15 or 20 minutes, I want to help you by sharing some tips and techniques about how do I master this last, literally 2 or 3 meters of your 100 meters journey. And it can make all the difference in the world. So this afternoon, those of you that want to take up my challenge that I laid down for you, that last question, I sat with it a day or 2 ago, and it was gorgeous. It's a beautiful sum. Ladies and gents, you need to constantly challenge yourself. Otherwise, you're not going to improve. Thank you so much for sitting and listening and hopefully enjoying this session.